Rewrite the following expression as the product of positive exponents, and then evaluate the expression when x is equal to 2. So they give us x to the negative 3 times 5 to the negative 2 times x squared. So the main thing to realize here is if I have something to a negative exponent, this is the exact same thing as 1 over that same base to the positive version of the exponent. So x to the negative a is equal to 1 over x to the a. So using this knowledge, let's apply it right over here. So x to the negative 3 power, we can rewrite as 1 over x to the third power. And then 5 to the negative 2, we can rewrite as 1 over 5 squared. And then finally, we have times x squared. And so we can multiply this out. In the numerator, we have 1 times x squared, which is just equal to x squared. In the denominator, we have x to the third times 5 squared. 5 squared is 25. And here you could say implicitly there is a 1. This is the same thing as x squared over 1. So in the denominator, we have 25 times x to the third. So this is going to be 25 times x to the third. And then we can simplify this even more because both the numerator and the denominator is divisible by x squared. X squared divided by x squared is 1. X to the third divided by x squared is just going to be equal to x. And you could use other exponent properties. You could say x squared over x to the third is the same thing as x to the 2 minus 3 power, which is x to the negative 1 power. But x to the negative 1 power, we know, is the same thing as 1 over x. 1 over x. Any way you do it, as long as you do it in a reasonable way, you should get the same result. So when we simplify it, we get 1 over 25x. Now, they want us to evaluate it when x is equal to 2. So if x is equal to 2, we get 1 over 25 times 2, which is equal to 1 over 50. And we are done. We rewrote the expression as a product of positive exponents. That's right over here. We made all the exponents positive. And then we evaluated it, and we got 1 over 50.